Okay, so this is the second part of section 5.3. We're going to be solving quadratic trig equations now. Basically, that just means we'll have something squared, so cosine squared, sine squared. Again, our goal is going to be to solve for x. We're going to round to the nearest tenth of a degree, and I'm interested in all solutions in the interval from 0 to 360. So once again, we'll do a few of these. Let's start off with, let's do 3 tangent squared of x minus 2 equals 0. So just like in the previous video, you can use your prior knowledge. You probably know that you need to add 2 and divide by 3. So we're going to do that. Tangent squared of x equals 2 over 3. Now this squared is a little bit annoying, so let's just get rid of it. We're going to take the square root of both sides, just like we would regularly. However, don't forget that there's a plus or minus that shows up when you do that. So this means that tangent of x is going to give me plus or minus the square root of 2 over root 3. Okay, so what I like to do at this point before I take the tangent inverse is just kind of break this apart to remind myself there are actually two equations here. There's tangent of x equals the positive square root of 2/3. There's also the tangent of x equals the negative square root of 2/3. Now, if you recall from our previous section in section 4.7, every single time we do this, we actually get two solutions. With one or two exceptions, we would get two solutions. So keep in mind that there's actually going to be 4 total solutions in this case. So when you're solving these trig equations, make sure you find all the solutions. Don't just find one and then call it good. Okay, so now we're ready to solve. We're going to go ahead and use the calculator. We're going to figure out what tangent inverse of the square root of 2/3 is. And we're also going to figure out what the tangent inverse of negative square root of 2/3 is. So here we go. I'm going to start plugging all of these into the calculator. So for this first one, I get 39.2 degrees. And then if I add 180 to that, I end up with 219.2 degrees. So there's two solutions. Over here, I'm going to get tangent inverse. Oops, I already wrote that. Don't need that anymore. Over here, I'm going to get 2 divided by 3. Negative 39.2. And then we're also going to get 140.8. But since that 39.2 is not, that's negative 39.2, I'm actually going to add 360 to that right away. And so I end up with 320.8. So if I was to now write all of these out, we would say the solution set would be 39.2 degrees. I'm going to go in order, so the next one will be 140.8 degrees. The next one is 219.2 degrees, and then finally we end up with 320.8 degrees. As a quick reminder, if you're working on Delta Math, you have your answer box, and you have a little plus and a little minus symbol. You need to click the plus symbol in order to add multiple solutions. So this is one way to write it, or you could just write x equals 39.2, x equals how we've been writing it. So either way is fine. But those are the answers. So something to keep in mind in these problems is that that there are 4 total solutions, so make sure you recognize that. When you take the square root, you get that plus or minus. Don't forget the plus or minus. Let's write that in a different color to kind of highlight it. So just a couple things to keep in mind there. Okay, let's go ahead and try a different one. So in that problem, we just had a tangent squared and there were no other trig functions. Let's say I have something like this: 5 cosine squared of x minus 2 cosine of x equals 0. Now in this case, if I add the 2 cosine over and then take the square root, I still have cosines on either side. So notice if I do this, it doesn't really make sense to take that square root, because yes, it will get rid of that, but then we'll be stuck with a square root over there. So I didn't really break any math, but overall this is not helpful for the problem. So what we're going to do instead is use probably one of the best F words in mathematics, which is factoring. Notice each of these has a cosine of x. So in this case, the GCF is cosine of x. So we're going to rewrite this as cosine of x, and then we're left with another cosine of x in here. But then this is just minus 2 equals 0. Now thinking back to what would happen if we didn't have trig, if this was another type of problem with just x's, we would next set each factor, so cosine of x and 5 cosine x minus 2, each of those would be set equal to 0. And now what's nice is we actually have a situation where we have 2 linear equations to solve, which aren't quite as bad as a quadratic. So the first one, we're going to get cosine inverse of 0, and then this one, if you solve, you're going to end up with cosine inverse of 2/5. Again, there will be a total of 4 solutions, so let's go ahead and find those. Cosine of 0, that's actually on the unit circle, or you can use your calculator, but you should get 90 degrees, and then you should also have 270 degrees. And those are exactly equal, there's no rounding. Over here, that doesn't really look like a -1, so let me redo that. Over here, we're going to end up with 2 approximate solutions. So I have cosine inverse of 2/5 gives me 66.4 degrees. And then if you remember the rules, the other one is -66.4. While I'm here, I know I'm going to have to add 360 degrees to that. So I'm actually going to end up with 293.6. Okay, so then my solution set, again, I'll put this in order, is 66.4 degrees, 90 degrees, 270 degrees, and 293.6 degrees. And you could always go back and double check that these work, so you can plug any of those back into the original, and you should end up with a correct equation. All right, let's do one more involving factoring, and this time we're going to take this kind of to the next level of factoring. So let's go ahead and solve 3 sine squared of x plus 4 sine of x minus 4 equals sine squared of x minus 3 sine of x. So what I notice in this problem is that I have some sine squareds on the left and a sine on the left, but I also have those same terms on the right. So the first thing I'm going to do is combine all like terms, just to kind of get a better sense of what I'm dealing with here. So we'll subtract sine squared to the other side, so that gives me 2 sine squared of x. And then we'll have to add the 3, so that gives me 7 sine of x and then I have that minus 4, and all of that equals 0. Okay, this still doesn't look great because notice there's no GCF to factor out. I can't just move stuff around and take the square root because that won't be helpful. So what I'm going to do real quick is kind of as an aside, remind you of something. Let's just say instead of 2 sine squared of x, it was just 2x squared. And then instead of sine of x, let's just say it was x, and then minus 4. Now if we had this is just a regular factoring problem where you take the first term, which is 2, and multiply it by your last term. You get negative 8. You need two numbers that multiply to negative 8, and then add up to positive 7. And so that would give me negative 8 and positive 1 would work. Negative 8 times 1 is negative 8. Negative 8 plus 1 is 7. And so then you would set this up. You could use your box method if you want, or you could go like this: 2x squared minus 8x plus 1x minus 4 equals 0. Now we factor out the GCF, 2x and then x minus 4. So I'm looking at this first part and then this part. Plus 1 and then x minus 4 equals 0. Now the reason I did this is because I've essentially just said, oh, I guess I should finish 2x plus 1 and then x minus 4. I've essentially just said, well, sine squared of x is kind of the same thing as x, and then I just solved it that way. It would work out the same way if I left it as 2 sine squared of x. You could follow all of these steps, and you would get the same result. So now let's go back to my equation over here and replace x with sine. So I'd have 2 sine of x, whoops, not a parentheses, 2 sine of x plus 1, and then I also have sine of x minus 4, and all of that would equal 0. So I have my two linear terms here. And go back to this like that. There we go. So I set each one equal to 0. 2 sine of x plus 1 equals 0. Or sine of x minus 4 equals 0. Solving would give me, let's just go straight to the final part here. X would be sine inverse of negative 1/2. And x equals sine inverse of 4. Plugging these into the calculator, or you might double check the unit circle because negative 1/2 does show up on the unit circle. You end up with negative 30 degrees, which means we also get 210 degrees. Let's go ahead and just add 360 right away. So we get 330 degrees there. If you type this into the calculator, you actually get an error. So sine inverse of 4 is undefined. That doesn't work. Sine can never actually give you an output of 4. So then my solution set is just 210 degrees and 330 degrees. So I would have ended up with 4 solutions, except this caused me to just have the 2 solutions. Okay, so those are quadratics. We saw 3 different strategies. One was factoring a quadratic using our multiplying a times c and then figuring out what multiplies to that and adds to b. The other one was factoring out a GCF, so a couple of different factoring techniques. And then the first one we were able to just take the square root because we had a tangent squared without a regular tangent. So that's pretty much all 3 methods you'll see for quadratics. We'll do one more video involving some other factoring techniques, but that's it for quadratics.